The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. I'm Sharon Dooley. I'm going to be the moderator today, and we have an interesting topic. We have Availability Groups 101, and our presenter is Adam Belovchuk, and we are very grateful to our sponsor, Dell Software, who makes it possible for us to have a raffle at every meeting, so you guys have a chance to win prizes. I am looking for speakers. Right now, I particularly need somebody for Wednesday, May 13th at noon Mountain. June, July, and August are wide open. As many of you know, we have 2 meetings a month. If you're interested in speaking, send me an email, dbavolunteer@sequelpass.org, or go to our website. You can contact me through our website. If you've not been to a Sequel Saturday, there's a whole mess of them coming up in the near term, and they're free one-day training events. They're all over the place in this country and around the world. We had a discussion, the speaker and panelists and I had a discussion before we started the meeting about where Joinville is, and it turns out there's one in France and one in Brazil. This Sequel Saturday in Joinville happens to be in Brazil. These are well worth your day. You may be asked to pay for lunch, but that's the only cost you'll have. And you'll find a lot of useful presentations. I know Adam's going to speak at the Philadelphia Sequel Saturday, as am I, and that's in the beginning of June. And there's usually 6 or 7 tracks and 5 or 6 presentations in each track. So look for one. There's bound to be one in your neighborhood. Past Summit is coming October 27th through 30th. You can save money by using the discount code that's on this slide. Write it down if you have a chance. If not, contact me, dbavolunteer@sequelpass.org. And you'll save $150. And the DBA virtual chapter will receive 1 free Summit Pass for every 10 registrations that use this code. So if we get one, we're going to raffle it off over the summer. So I need 10 people to use the code, register for Summit, and I'll have 1 free Summit Pass to raffle off. If you've never been to Summit, it's well worth it. It's a fabulous learning opportunity. And the earlier you register, the cheaper it is. We are one of many virtual chapters. Some of them specialize in a particular language. Others specialize in a particular technology or aspect of technology. And if you're interested in joining some of them, all you need to do is go to your past profile and select the virtual chapters that you're interested in, and that will put you on the mailing list, and you'll get mail from the other virtual chapters just like you get mail from the DBA virtual chapter. PASS is an all-volunteer organization. I mean, there's paid staff in the headquarters, but the work is done by volunteers. Nobody pays me to do this thing. Nobody pays any of us, okay? And you can volunteer for a short-term activity. You can volunteer to help at the summit. Each month there's an outstanding volunteer award, and at the summit there's a passion award that will be given to a volunteer who's made a significant contribution. So get involved and stay involved. If you're not a member, join. It's free. Now, Adam Volobchuk is going to do our talk. He's a database engineer and consultant with over 10 years experience in IT, ranging from customer service to server network administration to software and database development. He's the chapter leader for the Ohio North SQL Server Users Group, a frequent speaker and volunteer at past events, and he specializes in SQL development, performance tuning, high availability, and disaster recovery. And so now
Well, thank you, Sharon. That was quite the intro there.
Yeah, well, it's what you sent me. I'm having this I'm having this problem that I took put my PowerPoint in full screen, and my screen hasn't gone back to. Its normal size.
All right. All right. I think we transferred the screen over to me now, so hopefully everybody sees my screen at this point.
I can't get to the webcast because my screen's...
Well, I think Mike did. So, yeah, Sharon, Mike did. So we're good to go.
Okay.
My name's Adam Volobchuk. Like Sharon said, I work for Highland Software as a database engineer, and we're going to be talking about availability groups today. And my clicker now doesn't want to behave, so just a second. There we go. Sharon already did a pretty good intro for me. Essentially, the important part of this slide is my contact information at the bottom. If you want to, feel free to tweet at me at SQL Diablo, or go to my blog at www.sqldiablo.com, or email me at adam@sqldiablo.com. I'll show all that information again at the end of the slides, so you don't have to worry about jotting it down just yet. So really what we're going to talk about today is what is this concept of always on, and what are the different features that make up this term, this kind of marketing term. We'll take a look at how they compare to one another, and then we'll take a look specifically at availability groups and what an availability group looks like. We'll talk pros and cons of why I may or may not want to use an availability group. We'll look at readable secondary replicas and some of the things that we get from that, some of the benefits, the big wins and whatnot. We'll talk what do we have to do to set this up, what are our prerequisites on the server side and networking side and Windows side, that kind of thing. And then we'll do a demo where we'll set one up from scratch, and we'll do some tested failovers and just run an application while we do a failover to see how it behaves. Finally, we'll wrap up with a summary and my recommendations and references, slide deck, that sort of thing, and then a Q&A session. So always on, like I mentioned briefly, it's really a marketing term that Microsoft invented with SQL Server 2012. And so always on is really their high availability and disaster recovery features. And so within that is log shipping, failover clustering instances, database mirroring, which is deprecated and will probably be gone in 1 to 2 versions in the future, and then availability groups, which is essentially replacing database mirroring. And so how they compare to one another, we start off, we're not going to look at transaction log shipping too much because it's a little bit different than the other three. But we'll start off with database mirroring and then go into failover clusters and then into availability groups. So database mirroring, you're protecting a single database, and you can fail over from that database on one instance to that database on another instance. You can use a manual process to do that failover, or you can have a third instance as a witness to do the failover automatically when it detects a failure at the primary replica. As far as licensing is concerned, this is available in Standard Edition on up. Standard Edition does have a few limitations to database mirroring, but essentially it's available in that edition. It doesn't require a Windows cluster, so these could be two standalone. Yes.
Adam, excuse me, but
yes.
People are not seeing their full screen. They're seeing about half of it.
Oh, okay. Oh, that's really strange. All right, let me adjust my resolution. I did not realize that was happening. Let's see here. And it's still doing it, isn't it? All right, let me change my display mode. All right, I think that's better now. Does that look better, Sharon?
It looks better. I can see the whole thing, but it's still not filling the whole, you know, it's got, I've lost the ability to zoom.
I'm trying to switch apps here. Sorry. All right, bear with me for a second. I apologize for this, guys. And it seems to be messing with my... All right, sorry, just a second. I think the best I'm going to be able to do is this. How's that look, Sharon? All right.
Much better.
I think we are back in business. Okay. I might have to adjust some things when I get to the demo, but that's all right. Excuse me. So we'll start with database mirroring on the left. We go over to availability groups on the right. And so with database mirroring, again, we're protecting a single database, and we're protecting it on, from one instance to another standalone instance. We don't have a Windows Server cluster involved in that. If we want to have an automatic failover process, we'll need a witness instance to kind of watch the failure occur and switch over the connection and cause the failover to occur to that secondary. Like I mentioned earlier, it's available in Standard Edition on up with a few kind of caveats to what you can do in Standard Edition versus Enterprise. Essentially, you can be in, I believe it's high availability mode versus high performance mode. you can't really read from the secondary copy of your database with database mirroring. I put a bunch of asterisks there because you kind of can if you use a combination of database mirroring and also snapshots to take a snapshot of your database on your secondary. But it's kind of an out-of-band sort of a solution. It's not really baked into the product. With failover cluster instances, now we're talking protecting an entire instance. So now we're in the middle here of our table. And so if our entire instance fails on one server, or if we have a hardware failure of one of our servers, we fail over the instance over to another node or another server. And so when we do that, we're getting all of those nice instance level objects like our logins, like our packages in MSDB. Pretty much the entire instance fails over for us, whereas you didn't necessarily get all those server level or instance level things with database mirroring. As far as cost is concerned, it's kind of middle of the road. This is available also in standard edition for SQL, but it's more expensive because of the hardware you need. You need a SAN to back this up to have a cluster disk to run your instance out of, and so that makes this a little bit more expensive than just two standalone servers that are involved. You do need a Windows Server cluster, and that's what your that's what your SQL cluster sits on top of. You can't read from the secondary because essentially the secondary would be another server where SQL is shut down and not running. Now you can run a second instance of SQL Server on your cluster and have kind of like an active-active scenario where you have one instance running on server A and another instance running on server B, but talking just one instance by itself, you can't do anything with it on the other servers because they're not actually running the SQL Server services to host databases or other services. And then if you take a look at availability groups in that right-hand column, now we're talking kind of a mashup between the first two. So now we're protecting a group of databases to where if we have a failure on one server, the entire group of databases, one or more, fail over to another server. They're sitting on top of a Windows Server failover cluster just like they were before, but they are not necessarily clustered instances of SQL. They can be standalone instances of SQL. You can also have clustered instances be involved here to where a failover cluster would be one of your replicas or actually a couple of your replicas, but it's not necessary. As far as cost, it's by far the most expensive because this is an Enterprise Edition only feature, so you cannot use it in Standard Edition. It has to be Enterprise Edition. And because of the hardware necessary for clustering, just good solid enterprise-grade hardware, it's a little bit more expensive from that perspective as well. But what we gain out of this is we gain flexible failover, we gain the ability to read from our secondaries. So unlike database mirroring, where our secondary replica was in that restoring state constantly because it's constantly taking transactions and applying them back, but leaving the database in a restoring mode, you can have that with availability groups too, but you can also have the database be in a read-only mode. So the secondary replicas can actually be queried from. You just cannot modify data or structure on those secondary replicas. So what does an availability group look like? So this big blue square, that's your company. And the green squares here are your data centers. So we have one primary data center, we'll say it's here in Cleveland, Ohio, and then we have another DR site, maybe somewhere else, perhaps in Seattle or Chicago or some other part of the country or elsewhere. In between them we have a WAN connection, and that's a nice large internet connection that is hopefully very stable and pretty quick. And you'll notice at the bottom we have different subnets. So we have a 10.100 network here locally, and we have a 10.200 network remotely. This is kind of your standard disaster recovery scenario. In our data centers, we've spun up 3 servers. We have 2 of them being local, and those 2 local servers, server 1 and 2, they're going to be for high availability. So they're going to be for things like patching or fault tolerance, where if server 1 goes down, server 2 picks up immediately, or if we need to patch server 1, it will fail over to server 2, that kind of thing. So that's high availability. But then if our entire data center goes down, or if we lose access to it, or something just really bad happens, then we're talking disaster recovery, where we'll manually fail over to our disaster recovery site into that server 3 that's over there. So on these servers, we install standalone instances of SQL Server, And we can put some set of databases on any of these. These are totally different databases, not related to one another. Maybe you have just some ancillary systems that are on them, or a development database on one. Totally fine, totally normal, totally possible. But let's say some important application comes along that we want to protect, say a line of business application or a document management solution like OnBase, and you install that on your what will become your primary replica, your main server. But you want to protect that database, and it has maybe a couple others that go with it that are related to it. To protect that and to bring it into an availability group, we go ahead and create the availability group. We then synchronize that data across our replicas. And at that point, once we've done that, we have an availability group created where we're synchronizing transactions that are happening on the primary, which is server 1. They'll be replayed onto server 2 and server 3, and that keeps us in sync. And if anything bad were to happen to server 1, server 2 would take over as the new primary replica where read-write activity is happening. And so on server 1 today, it's our primary replica. That's where read-writes happen. Servers 2 and 3 could either be just like database mirroring. They could be in a restoring mode and we can't touch them, but they're there in case something bad happens. Or they could be in that read-only mode, and maybe on server 2 we're running a reporting workload, or maybe even backups. And then server 3, being our DR site, we're probably not going to do any kind of activity on that server. It's really just there in case something really bad happens and we have to fail over to it. And then there's another component to this piece that makes it, or to the solution that makes it really, really quite nice, and that's called the listener name. So the listener name is, essentially it's a cluster resource name, or it's a combination of a DNS name or a domain name, like Adams Rockin' Server, and an IP address. And so what that does for us is that's where we connect our application to. And the application connects to demo availability group is maybe the name of our listener in this case. And what we do with this listener name is it always follows the primary replica. So right now the listener name would be on server 1 because that's our primary replica. And that's who's hosting it, that's where it's running on. And it would have the address 10.100.100.200. And so our application, that's what the connection string would use, would be just the name of that listener. It would be demo AG or demo availability group. But really it's connecting down to instance 1 on server 1. But when a failover occurs, and we fail over from server 1 to server 2, the listener name also follows that failover. So now the listener name moves from server 1 to server 2. Server 2, the database goes from a read-only or a restoring mode into a read-write mode. And now our application is connecting to server 2 instance 2 for our transactions to occur. The application didn't need to know that failover occurred, and it will actually in flight reconnect itself and start processing transactions. Now any transactions that were open and running while that failover occurred are actually going to error out and fail over, or I'm sorry, and roll back, so they won't be committed or successful. But if we try them again, they will immediately start working once the failover process is finished. So that's how an availability group is set up, and that's how one of them works. Let's talk a little bit more about the readable secondary replicas and what we can do with those. So with readable secondary replicas, there's two big things we get as wins here. One is the ability to run read-only queries off of our secondary replicas. So that's server 2 and server 3. We could run read-only queries, select statements off of those servers. In order to do that, there's a couple pieces that make that happen. The first is a new keyword in your connection string called application intent. And if you put application intent equals read-only, that tells the primary replica, because again we're still using the listener name to connect. So our application that's running our select statement that isn't going to do read-write, it's only doing selects, it still goes to the listener name, but now since it's saying application intent equals read-only, it's telling the primary server it's okay to offload that activity onto another replica. And that's where the second bullet point comes into play. We create what are called read-only routes. And those read-only routes tell each server, hey, when you're in the primary mode, what do you do with the connection that comes in requesting read-only? And so you'll see in our demo, we'll offload that read-only to another server. So when instance 1 is our primary, it will actually offload the read-only activity over to instance 2. And if instance 2 is not available, then it will go to instance 3. And so together with the three pieces together, the listener name, the application intent equals read-only in these routes, you'll automatically offload your workload for read-only traffic to other servers. And it helps you to get a better utilization of resources. It helps you to kind of spread out your workload onto your different servers, which you couldn't do before with failover clusters. You couldn't necessarily do it before with database mirroring either, because the other replicas were not in a usable state, whereas now they're in a read-only state, so we can go ahead and run workload on them. And then finally, if we're running, say, a reporting workload off of one of our secondaries, it probably has a different need for statistics than what our OLTP activity would have. So if there's a missing statistic that we come across on our secondary replica, even though it's read-only, you wouldn't normally be able to create that statistic in flight and have the most optimized execution plan. It actually will create that, but it will store it into TempDB on that instance. And so it's a nice kind of workaround that Microsoft did for us. They said, okay, we see that you want to run this workload. You can't modify the database. Statistics are really important to how execution plans are generated and to running queries efficiently. So we'll go ahead and let you do that, but just in another place. We won't put it into the application database. We'll put it into TempDB. So that's a pretty big win for us. The other big win is the ability to run backups from any replica. And so the primary replica is where we can do read-write activity, and that's really where our full backup must be run, mainly because it's going to affect your transaction log. And so it's going to write in when the last backup was taken. Copy-only backups don't do that. So we can run them on any replica. So a copy-only full backup, that really can run anywhere because it doesn't impact your log chain at all. A differential backup, that also impacts your log chain. It says it keeps track of when the last differential was taken as well, and so that has to run on the primary replica. And then finally, transaction log backups, and this is where it gets interesting because you see it says any replica, and normally I would think, well, that it would follow the pattern of the full and the differential, where we're modifying the log chain, where we're going to write in when our last transaction log in. So why can that run anywhere? And the idea being is that we can run our full backups from our primary replica on sort of off-peak hours, maybe on an odd time of day on a Sunday, and then differential backups maybe an odd time of day on Monday, Tuesday, Wednesday, Thursday, Friday, and then throughout the day when we might impact our users, that's when we run the transaction log backups from a secondary replica, and so that way it doesn't impact the I/O or the CPU workload happening on our primary replica. It would only happen on the secondary. What's really cool is when that happens, when I take that transaction log backup on the secondary replica, since it can't write that to the transaction log of a read-only database, it actually communicates up to the primary and says, hey primary, I took a backup. The last LSN that I backed up was this. Go ahead and checkpoint the log for me. And so the primary will do the checkpoint, and then it gets replicated out to the other replicas. The other cool thing is if I take a full backup from the primary, another differential from the primary, and then say a transaction log backup from replica 1 and another one from replica 2, all three of those, or all four in that case, all four of those backup files are one contiguous log chain. So I haven't broken the chain by doing that, by backing up from different servers. Again, because it translates that LSN, or transmits it up to the primary replica, and they're all sharing the same log chain essentially. And so in this case, Microsoft recommends, if you're going to offload your backups in this way, just back them up to a share that they can all reach, and then having all those files together lets you do point-in-time recovery to anywhere in that window. And it's actually a pretty nice solution. So pros and cons. Essentially, why we'd want to do this is to better utilize our resources and to improve our performance. The idea being kind of scale out. And if we can offload our read-only activity, offload our reporting activity, offload our backup activity off of where we're doing our inserts, updates, deletes, then we can gain performance for our OLTP or our line of business application on user activity, those quick hits that an OLTP system typically does. That will improve the performance of that because it's not having to serve any longer running queries. It's not having to serve any more selects than it needs to. It's not having to deal with the overhead of backups and that kind of thing. That can all run on a secondary replica. In addition to that, geo-clustering is very easy, because when I talked about a failover cluster, if I were going to stretch that to be, in the scenario where I have another data center involved, I would have to have some kind of SAN replication or similar technology that makes it possible for me to replicate the cluster disk for my failover cluster over to that other data center. In this case, since we're running standalone instances, there's no need for replication of that nature at all. We don't even need a SAN at all. We could run standalone instances on local storage and let SQL Server manage the replication process of sending those transactions to the other replicas. We also have more flexible failover. So the mechanism that detects a failover has basically 5 settings that you can set on how severe an event has to be before it triggers failover. One of them basically being, if total down, I can't reach the servers is obviously the most severe level, but then there's other levels like the latency is high, or things like that can cause a failover, which is an improvement over what we had in the past, where we really kind of had a true or false scenario. If I can get to the other server, run the health check, and it comes back and says it's up, then we're up. But what if that took 5 minutes to run? Maybe I want that to cause a failover. We have more flexibility there. Another neat feature is called automatic page repair. So if I run a query, it could be a select statement off of a read-only replica, or it could be any kind of a statement on my primary even, and it encounters a torn page or a corrupted page. It will actually reach out to another replica, ask for a good copy of the page. If there is a good copy of the page, that gets sent across the replication mechanism, overwritten into the file system, so now we have a corrected copy of that page, and my query completes. It doesn't error out like it normally would if it encountered corrupt data. So that's a really nice win. It might take a little bit longer to run, so you might see some latency there, but instead of erroring out, it will actually repair it in flight and continue on. So that's pretty nice. I believe that's also available in database mirroring as well. You don't need a witness server, so we don't need to dedicate an instance just to kind of watching for bad things to happen. That's what our Windows cluster does for us. And we have a really nice, robust set of tools, dashboards, commandlets that you'll see in the demo that help us manage this, set it up, monitor it, and maintain it. So that's my sales pitch. Now Microsoft owes me a pretty big commission check. But the other side of the story here is that, and you can probably see from the red dollar signs, there's definitely a cost to all of this. Being Enterprise Edition only, that right there makes this very expensive, and also the licensing scheme, because we're going to be licensing each of our replicas at the Enterprise Edition SKU. So now it's kind of really expensive to the really expensive power. It becomes expensive very fast. Now we do get a free replica if we're on an SA, and if we have, also if we're not using that replica as a read-only replica. If it's basically in a non-readable state or in that restoring state, and we're not running any other workload from it, it's not hosting any other databases, it actually is kind of a free standby instance, just like with database mirroring. So on database mirroring, your second instance could have been free as well if you were not using that instance for anything else other than just kind of being a warm standby. So at least that's nice. Microsoft gave us that same kind of freebie license that they did with database mirroring. Also, quorum configuration and maintenance, basically setting up a cluster, it can be challenging. It can be challenging to get right, and it can be challenging to keep stable. And especially when a failover occurs or a failure occurs, and we have to adjust the settings of quorum to keep our cluster in a consistent state. So if you don't have that expertise in-house already, you'll need to grow that expertise, either hire it in or basically train it up essentially. It can be a barrier to entry. And then finally, we're only protecting that group of databases. So we're not protecting our instance level objects. So our logins, our roles, our endpoints, SSIS packages, none of that is really being protected automatically for us. Now, there are methods to keep those in sync and to take care of that for us. For example, you can create logins with the same SID on all servers, and then you don't have to remap your logins. Jonathan Cahias from SQL Skills also has a nice script that will kind of compare your instances and tell you the differences and give you a script to actually bring them into sync. And there's just other ways to do that as well, but again, it's kind of an out-of-band thing. Availability groups don't take care of that for you, so you'll have to have some mechanism to do that. So prerequisites, what do we need in order to set up an availability group? Well, first of all, we need a Windows Server cluster, right? So to set up a Windows Server cluster, we need Server 2008 or above, Enterprise Edition or above. Although I'd really, really highly recommend going with Server 2012 R2. There are a lot of new enhancements and bug fixes in that version of the product that better support your availability group. And I can't stress enough how critical the Windows cluster is and how much of a foundation it is for your solution. So if there are any bugs or hiccups or just oddities about how your Windows Server cluster is behaving, if it's not failing over properly, if it loses quorum and shuts down, anything weird like that will be exacerbated in SQL. You want your Windows cluster to be rock solid. And so when you're setting up an availability group, the first thing you want to do after you install Windows and put them in a cluster is test that. And by tested, I don't mean just click failover from the interface. I mean actually unplug power cables, unplug patch cables, simulate real-life failovers, real-life failure events, and just make sure that your servers respond to that properly. Then after you've done that, then you install SQL Server, but not before. Now, if you are running Server 2008 or 2008 R2, there is a hot fix that I mentioned here that allows you to set the node voting. And node voting is important because, again, it controls how failover occurs and what scenarios might shut down our cluster if we lose quorum. And so it's important to us to set that up properly. And Microsoft has a number of recommendations that they make. I have a link to a nice white paper of theirs on my blog that you'll see a link to at the end that talks about the different scenarios you may have and then what they recommend as being the quorum configuration. And I'll talk a little bit more about that in the demo as well. So then once we have our cluster for Windows set up,